Okay, now, Amber and Peter each baked some cakes and cookies. The total number of items baked by each of them was the same. So that's easy. Just draw the same, always draw model. Easy. That's the easiest part. When two items are the same, you draw two models. Now, Amber used 1540 grams of flour to bake 3 cakes and some cookies. So 1540 grams cakes and some cookies. Jaden, be quiet or mute yourself. Okay, so the total number of items baked by each of them is the same. So Amber used 1540 to bake 3 cakes and some cookies. And Peter baked 6 cakes and some cookies with 2605 grams of flour. Now, what is equal is the number of cakes and cookies. It is not the mass of the flour. Okay? Be careful, huh? So what is equal is the items. Number of items are the same. Not true. So for Amber is 3 cakes and some cookies. So I put a question mark. For Peter, it's 6 cakes and some cookies. All right. Now, this is the difference. This is where the difference is. The total difference between the flour used is actually lies here. Okay? Because over here, the number of cakes are the same. Over here, number of cookies are the same. The difference is actually in this box. And this is where the difference in flour happens. Okay? Now, the difference between, over here I can see, so we know that number of cakes and cookies are equal, right? So the number of items in this box must be equal to 3, because the number of items here is the same, the number of items here is the same. Inside this box, the number of items got to be equal to 6 minus 3. So the number of cakes and number of cookies here, number of cookies here and number of cakes here must be 3. So the difference between 3 cookies and 3 cakes has a mass of 1065. Any question? Any question? The difference between the mass of 3 cakes and 3 cookies must be 1065. No question? So good. Must understand reasoning, huh? So the difference between 1 cake and 1 cookie has to be 1065 divided by 3. So 1355 is the difference in the mass between a cake and a cookie. All right, the statement is very simple, but the reasoning, the understanding of the reasoning is very important. Okay? I hope you get the reasoning right, not just by fluke and get the answer, because the statement is very simple. This type of question appear in PSLE like 3 times already. 3 times. Okay, maybe 3, but certainly 2 times. This kind of question. And this is only the basic. All right, this is only the basic. It appears in PSLE at least 2 times using this concept, but in a more complicated setting. Okay, so you must understand the reasoning. Question number 4. Let's do. Okay, let me explain to this question. Okay, no more trying, just listen. So John and Peter baked some blueberries tarts, which are either small or large. The total number of tarts baked by each of the boys was equal. So this is the key. They both bake equal number of tarts. The small and the big, the large, they are equal. Okay? John used a total of 118 blueberries for 14 small tarts and some large tarts. So all the tarts is made out of small and large. So let's talk about John. Okay, John baked 14 small and some large and used 118 blueberries. Peter used 100 blueberries and baked 20 small and some large. Okay, so the total items are equal between John and Peter. The difference between them lies here. This is where the difference lies. Okay, and this difference is the difference between the number of blueberries used. So over here, the difference between the blueberries used in the large tarts and the small tarts is 18. And how many large tarts are here? 20 minus 14. And how many small tarts are here? 20 minus 14. Okay, so there's 6 large tarts here and 6 small tarts here. Okay, there are six large and 6 small. And the difference between the blueberries in the 6 large tarts and the blueberries in the 6 small tarts is equal to 18. Any question? Any question? Need me to explain that again? If you need to, just write in the chat. If not, I'm going to assume you're okay. Okay, everyone seems to be all right. So the difference between the blueberries in 1 large tart and 1 small tart will be 18 divided by 6, 3. So that is the answer to part A. How many blueberries are needed for a large tart than a small tart? So they're asking the difference. So it's 3. How many more blueberries would John need if he were to bake only large tarts? John. So look here. Every 1 large tart has 3 more blueberries than small tart, right? Everybody agree that 1 large tart has 3 more blueberries than a small tart. Now look at John. John already baked so much large tarts and baked 14 small tarts. Now I want to convert these 14 small tarts into large tarts. Every small tart to bake into a large tart, I need 3 more blueberries. All right. So how many more blueberries do John need if he want to bake these 14 small tarts as large tarts? It will be 14 times 3. 42. Simple, right? You don't get it means you didn't really grasp the concept. The steps to these questions is very easy, but the concept is not easy to grasp. If you question, you better ask me. Okay, pay attention. So Yanni and Amber have an equal number of notes consisting of both $2 and $5 notes. So Yanni got some $2 and some $5 notes. Amber also. Okay, Yanni has $32 notes and Amber has 6 $5 notes. The total amount of money Yanni has is $39 more than Amber. So this is a quantity and value thing. But we're talking about difference here. So let's draw a model representing equal number of notes for Amber and Yanni. This is key. So we're comparing things when they are equal. Now, we know that Yanni has $32 notes. Okay, let's continue. Yanni has $30, Amber has 6 $5. Okay, let's draw a model. $32, then the rest are $5. Okay, but we do not know. Let me finish up the thing. Okay, so we know that Yanni has $32 notes, but we do not know how many $5 notes Yanni has. We know that Amber has 6 $5 notes, but the number of $2 notes we do not have. So when I draw the model, I will want to draw the $2 notes on top of each other. and the $5 notes on top of each other. So don't switch position. You switch position, very difficult to do. Okay, so when you don't switch position, you can actually compare. And then you, from here, you can see the difference between their values, their total values, is a result of this area, where the extra $5 notes here is more than the extra $2 notes here. Outside this box, the number of $2 are equal here, the number of $5 notes are equal here. Okay, so the difference is only here. The number of notes here is simply how many? We do not know. This is because it's a question mark, so we don't know. Okay. But we know the difference between $5 notes and $2 notes is $2. It's $3. We also know that the total difference between the value here is $39, given the question. So total, all the $5 notes here, minus all the $2 notes here, the difference is $39. Understand that? Audrey, can you hear me? If you cannot hear me, it's your mic, you know. I'm speaking very loud now. Or is your speaker? Can you still hear me, Audrey? Press the volume, increase your volume. Okay, so the $39 difference comes from here. All the $5 notes here minus all the $2 notes here gives you $39. And the numbers are equal. The difference between the $5 and $2 $5 and $2 notes is equal to $3. So $39 divided by $3.13. This will mean that there are 13 pieces of notes here. Okay, Audrey, I wait for your parents to come and fix your computer. Everyone can hear me? Everyone can hear? Okay, okay. So I repeat again, Audrey, one more time. So I was saying that, Audrey, listen, I was saying that the difference between the total difference of $39 is here, okay? It is where all the extra $5 notes here, for extra $5 notes that Yenny have, compared to the extra $2 notes that Amber have. All right. And when you compare the total difference between the $5 notes here and the $2 notes here, the total difference is $39. Outside this box, the number of notes are equal. A number of $5 notes are equal, number of $2 notes are equal. So the value will be the same. The value difference will be zero. Okay. Now, this total difference, $39, come about because of the difference between a $5 notes and a $2 notes, which is $3. So if I use $39 divided by $3, I get 13. 13 represent 13 pieces of notes here. Okay? There are 13 pieces of notes here. 13 pieces of notes here. How many notes does each of them have? So, since the number of notes are the same for Yenny and Amber, I can either use the information on two bars to calculate. So you can see this is 30 plus 13 plus 6. That will give you all the notes that Yenny and each of them have. Can you see that? 30 plus 13 plus 6. Or you can look at Amber. 13 plus 6 is this portion. Then this portion is 30. Either way, it's just 30 plus 13 plus 6. Okay? So Yenny's notes is $5 notes will be what? 13 plus 6. Okay, 13 plus 6. 13 plus 6. Which is 19 plus this 30 here. And you get the notes that Yenny had, which is also the notes that each of them had.